Good afternoon, everyone, and welcome to today's webinar hosted by the Smart Networks and Services Joint Undertaking. My name is Pavlos Fournogerakis. I'm Deputy Head of Programs in the SNS JU, and I will be your moderator for today's webinar. I'm really delighted to have you with us as we try to unveil the 2025 Top 10 Key SNS JU Achievements, showcasing the most significant and most innovative results that are produced by 63 SNS JU projects funded under calls 1 and 2. For this first selection of SNS JU key achievements, we focused on those 63 projects that are already in the second and third year of implementation, with a few of them already finished. These projects actually represent a part of our SNS JU portfolio of 79 projects. Since the start of the program, we have already 3 calls, but next year we expect more than 20 projects that will be added in this portfolio, building a very strong portfolio of around 100 projects and with more than 600 million euros of EC funding. So before we proceed, let me present you some practical details and housekeeping rules of the webinar, and then we can move on to the next slide. So the event will be recorded. All the presentations and the recordings will become available on the event page and on YouTube. Please try to keep your mic always muted if you are not presented. Of course, our colleagues here will make sure that everybody is on mute if it doesn't have to speak. Please use the chat box to ask questions during the presentations. Again, presenters and other colleagues may provide answers directly in the chat, but you will have definitely the opportunity to speak, and you can raise your hand during the Q&A session at the end of the presentations. Moving on to the next slide and the very tight, to be honest, agenda. Besides the focus on top 10 key achievements, today's session will also introduce you to the brand new SNS Key Achievements Repository, which is an online platform created to bring visibility and accessibility to all project results across the SNS community. You will also get an inside look at the evaluation and the selection methodology that we have used to identify this year's top 10 achievements from many high-quality results. Most importantly, as you see in the second side of the slide, we'll be hearing directly from the researchers and innovators behind these achievements. Each selected project has 5 minutes, and this is very strict due to the tight agenda. So it has 5 minutes to briefly present the achievement that earned its place in the top 10. And we expect that the projects will offer insights into the impact and the potential to shape European digital connectivity. So without further ado, let's get started with the first speaker. So I'm very happy to welcome Thibaut Kleiner to give us some opening and welcoming remarks from the European Commission side. So Thibaut is Director for Future Networks at the European Commission's DG Connect, and he's of course Chair of our SNS JU Governing Board. So Thibaut, please go ahead when you're ready.
Thanks a lot for inviting me in this very important workshop today. I think that you said it already. This is an opportunity to exchange and to report on what the SNS JU has achieved in the recent past. We are very proud of this joint undertaking. I think that when it was created a few years ago, really was also a vision to try and bring together not only communities that are involved in research, but also different sectors that can benefit from 5G, from 6G development, and how this can transform really our economic and societal developments in Europe. when we created the SNS JU, I think that we didn't have in mind that AI would be so critical in terms of technology developments and accelerating really the transformation and the transition towards networks that are adjusted more and more automatically. When we launched the SNS JU, we also had in mind that 5G would be deployed, maybe on a more rapid pace on the basis of the 5G action plan that had been adopted a few years back. But I think today, looking back at what has been achieved by the SNS JU, I think we can be very proud of the results. I mean, if you look at the top 10 achievements, I think, and we will hear more about this today, you see that there is really a diversity in terms of the research results, things that are really essential in terms of how network technology is developed. I mean, I think from the issue, like for instance, high capacity point to multi-point transmission. I think this is something that we have been talking about for many years, or experimentation of infrastructure as a service, you know, also is a technology that has been discussed, but that the SNS JU is now bringing to a new level of development, as well as federated portal or test beds, element on architectures, on energy consumption. I mean, all these results are very significant in terms of research and technology. But what I find really exciting is that with SNS, we are, through the public-private partnership, the ability to show how the technology can be translated into very concrete results. And that's really, I think, that what today is unique somehow. We can show that it's not just about a very vibrant research agenda where Europe really is at the edge, is really leading on the technology, but is really an opportunity to take these technology results to experiment and to actually have real impact in terms of how we develop new standards, how we prepare the next generation with 6G in terms of network technologies, and how we can actually incorporate these innovations in the products, in the services that not only the telecom sector, but actually much more broadly all our industries can really use and can innovate upon. So my message today is really one of, as I said, pride of the results. I think that we are right to spend taxpayers' money on this joint undertaking and to develop this research agenda. I think we are right also with the cooperation between public and private. I think this is really excellent result. But I also want to say that we are at a real turning point. There is a lot of questioning about European technological leadership, about European dependencies actually in many areas. And I think that today we have the opportunity to show that basically the future is in our hands. It's up to us to take these technologies and to disrupt what people think can be done, to show that actually we can invent new products, new services, make actually European tech even more vibrant, but also take it really to the customers, to the users, and show that this is actually not only exciting, but it's also making a big difference for our welfare, for our solidarity, and also for the opportunity of more competitiveness, not only in the telecom sector, but in the many verticals where we can use and implement these technologies. So in essence, I wish you really a good discussion today. Have a look at the reports. They are really very interesting, but also engage from wherever you are. I think that SNS JU is a focal point and is also a place where we have very soon a new opportunity for these stakeholder groups, where we also are discussing the monetization of 5G and 6G, and where we want really to build also a business case for investing in Europe, in networks, but also, broadly speaking, in our digital environment. So that's what I wanted to say, and back to you.
Thank you, Thibaut, for your insightful presentation. Really valuable to set the scene and prepare the context and the reasoning, the rationale behind this important initiative. Thank you very much. So let's move on to Erzsébet. I would like to invite Erzsébet Fittori, our Executive Director and the Smart Networks and Services doing Undertaking, who will also provide some welcoming remarks. Erzsébet, over to you.
Thank you very much. Let me echo Thibaut's words. I am extremely proud that we are presenting and discussing today the key achievements of the SNS JU's projects. Very much in this spirit, if we could show perhaps my first slide, what I wanted to share with you is actually an overview of the key achievements at program level and impact at program level. As Thibaut said, we are implementing EU funds, taxpayers' money, and our main objective is for research and innovation projects to actually have an impact on society, on socioeconomic progress, on industrial competitiveness. And from the very outset of the program, actually, I think the vision with regard to 6G has taken this ambition very much at heart, and I think it is a cornerstone of the SNS JU program from the very beginning. What you can see on the slide is basically the measurement, the key performance indicators that SNS JU has published in its annual activity report this year. We are reporting on a number of key performance indicators exactly in the spirit of showing that there is an important impact. And there are many shown on the slide. So one to pick out is actually standardization contribution, which is extremely important to ultimately translate technology innovation into scalable production and products and services. Sustainability, energy efficiency, or indeed security are very clearly aligned objectives with European policy priorities. If we move on to the next slide, it is one of my favorite slides, so apologies to many of you who might have seen it in previous presentations, is really, I think, to take a quite systemic, holistic approach to move from research and innovation to actual impact, which has very important interim steps from technological development to standards to actual deployment, which all need to be successful components of the process to ultimately get to that impact. And of course, it's a very nice figure, but it is easier drawn than actually done. However, I am very proud that today we will be showcasing 10 the really important achievements. And I think what we can highlight is that, for example, 6G reference, season, and Superior have been frontrunners in moving research and innovation into significant technology development. Or if we look at the contributions to standardization at European and global level, 6G Shine has been also doing that. I am just calling out a few examples. Moving from standard into trials and testing is very important to actually ultimately develop products and services and to serve the vertical sectors. So 6G Sandbox, Sunrise 6G, 6G XR, Imagine, B5G and TrialsNet are very good examples of such testing and trials. And finally, HexoX2, one of our, actually our flagship project, which also will be presenting later, is a clear example of how the SNS JU program is delivering concrete sustainability solutions for 6G, pioneering zero energy devices, for example, that harvest ambient energy to operate without batteries. Sounds extremely futuristic and promising. So I would like to congratulate to all of the projects that have participated in this process. A special congratulations to the top 10 projects for their outstanding contributions, and many, many thanks for the organizing team and all of the participants for all your support and dedication. I very much hope that this event will leave you with further inspiration and motivation for a more competitive, more sustainable future for the European connectivity sector and the European industries that we are serving. Thank you very much. Pavlos, back to you.
Thank you, Elizabeth, for your valuable insights about our program, impact-driven SNS program, and of course the significant KPIs that we have already achieved. Now we have finished with welcome and opening remarks, and now it's time to move on to the next session. And I'm very happy to welcome Kostas Trichas, who is a 6G Industry Association senior researcher and the SNS JU Technology Board Chairman. And happy to say that Kostas has made an excellent job in coordinating all this process for the selection of the key achievements. So Kostas will present us about the development and selection process of the top 10 key achievements. Kostas, the floor is yours.
Thank you so much, Pablo. Good afternoon, everyone. I'm very happy to be here. Indeed, as in my capacity as a Technology Board Chairman. For those of you that might not be aware, the Technology Board is the collaborative body of the SNS JU technical managers. It's practically where all the technical managers from all active SNS JU projects we get together and discuss views, challenges, results, and try to come up with common output and common learnings and insights from the amazing work that the projects are doing. So if we can move on to my first slide, what I'm going to do here today is practically explain to you why did we go about generating the SNS JU key achievements and why did we need this top 10. So as I mentioned, there is a lot of work happening. We actually at some point had 79 projects working in parallel, and it can be said that sometimes it's hard to get the broad picture and the high level view of what it is that the projects are coming up with and to indicate their great results. So we needed to find a way to track the most significant outcomes coming out of the projects and to provide a nice overview of the technological and experimental contributions coming out of the projects. We also wanted to highlight the impact that this has in real-life developments, in the 6G deployments and 6G standardizations, and the future deployments to come. And of course, we are proud of our work. As was mentioned before, there's a lot of funding and resources and effort going into all of these projects. So we think it's appropriate to celebrate the excellence coming out of the European research and innovation landscape. So we can move on to my next slide. Thankfully, when building the process for the key achievements, we didn't have to start from scratch. We took advantage of a similar activity that was taking place in the 5G PPP era, so the predecessor of the 6G SNS JU. But it really followed a completely different path. So we did a complete overhaul. We wanted to update and adjust the process to today's standards. We created tailored categories for the key achievements, as hopefully you know. So we had 5 different categories, and some of them even had subcategories matching to the specific technologies or experiments taking place within the SNS JU. We streamlined the way to get the input from the projects. We had to come up with specific templates and a way of working, and we actually created an online form to facilitate this. And of course, we wanted to make sure that this is visible and well known to the entire community, we came up with a dedicated webpage for the SNS JU Key Achievements. And we came up with the top 10, which is a new aspect, something that was not done in the 5G PPP era, exactly to, let's say, motivate the project and to also make it easier for us to celebrate excellence. As we stand, I mean, this was considered a successful exercise, but of course, we'll always learn as we go. And we are in the process now of really applying the lessons learned from this first edition of the Key Achievements exercise to hopefully make the next edition even better. If we can go to my next slide, I can explain a little bit more about the process. So we did come up with an evaluation committee, people that were tasked with reviewing and scoring the different achievements as reported by the project. It was quite wide expertise and different backgrounds, coming both from current and previous chair and vice chairpersons from the various collaborative bodies, from the SNS JU office, from DigiConnect, and you name it. So we made sure that each key achievement was reviewed by at least 3 different evaluators, and that we applied some appropriate weighting to make sure that the results were normalized and to mitigate any reviewer bias. So we did our best to be as objective as possible. We had multiple roundtables with this committee, as it was not an easy job for us, as there were multiple excellent achievements. And coming up with the top 10 really required a lot of discussions and looking at things from various angles. We had also already published the evaluation criteria, so what would the committee be looking at when scoring. Let's move on. I think the criteria was clear, and we did our best to be as fair as possible. So my next slide, please. I think we'll describe more or less the timeline that this followed. I mostly put this here just to give you a feeling as to what a complex process this was to collect all these items. We started from in April 2025 with the process, moving on to May to produce a template and agree on the committee, get the input from the projects before the summer break, and we spent most of the summer trying to evaluate this excellent input. So with the relevant steps that remain, we ended up in November to be able to announce the top 10 publications, and now to be able to celebrate it in this event. So if we move on to my next slide, I would just provide the overview of what this means. We received 198 key achievements in total from the 63 projects of Call 1 and Call 2, which were mature enough to share results with us at that stage. Under the 5 agreed categories, I would like to highlight the fact that there's a lot of excellent work besides the top 10 that we're here to celebrate today. That only represents a 5% more or less of the key achievements. There's a lot more excellent work, and I would invite everyone to check out the very nice interactive webpage that we have for all the SNS JU achievements. And today we're going to explore, of course, our top 10 winners across the 5 categories. So with that, I think I would conclude. My next slide simply provides an overview of the top 10. But I won't take any more of your time. I think we're going to hear one by one. And many thanks to all of you, to the winners, and to all the projects for participating in this event. Pablo, up to you.
Thank you, Kostas, for shedding some light on the full process. Indeed, very demanding one. I can definitely confirm that. And once again, congratulations to the very efficient coordination of the process from the beginning till the end, and the selection of the top 10. Without further ado, let's now move on to the next presentation. So I would like to welcome Audrey Bienvenu, who is a project communication manager at Eurescom, and who will walk us through this online repository, the key achievements tool that Kostas has also mentioned in his presentation. So Audrey, over to you.
Many thanks, Pavlos, for passing me the floor. Can you see my screen correctly?
Yes, we can see this.
Okay, very well. So I will not go in for the detail because the older speakers presented very well the tool already. I will just show you very briefly how it works. So when you arrive on the nice SNS JU website, you go directly in the menu, and under SNS JU results and tools, here you may find a lot of very interesting tools. And the key achievement page will be just here on the first one. When you arrive here, you will first land on the preview page, when you'll be able to first have an overview on how many key achievements were collected among the 63 projects. There you have buttons where you can explore them all directly, or the top 10s, and you can decide to browse by category here. All of the data here and the buttons are interactive, so if you want to have an overview first by number, it's full of nicely designed charts by my colleague Francisco Spiri. And everything here is interactive, so you can have a look and decide to explore by preferences. If you click directly by the top 10, you will see here the top 10 key achievement from 10 projects selected that will be presented after. But if you wish to browse all the key achievement and then a current view to do so, then all of them will be nicely available here. When you overlay them, you can see which category they are and subcategories, and you feel free to open any of them. There will be the project, all detail, a description, sometimes an illustration, and the reference. So if you need more reading, then you can just go there and have a look. Of course, everything here is possible to be filtered by category. So category 1 on significant technology development, experimentation, vertical, sustainability. If you need more filtering, you can also decide that you want to see the key achievement by projects. It's possible, and even by subcategory. So there, if you want to see more about digital twins or media and reality, extended reality, feel free. And if in all of that you still don't find the key achievement of your choice, you can feel free to tap here. And if you're looking for IoT, then the key achievement of your choice will appear. So I'm not gonna lend more time on this presentation. I think it's pretty intuitive, and I would like to thank all my colleagues at EURESCOM who helped develop this, and also the SNS office who was really helpful in all this domain, and of course the project, because without them and the technology board collecting all of this, then for sure this page will not be here. So I really encourage you to go through it, and many thanks.
Thank you, Audrey. Excellent indeed. That's very nice tool. And I also invite everyone to further investigate. I see that our colleagues have already put the link also on the chat, so you can already start navigating through this tool. So many thanks again to the team. Now I think it's time to move on to the real presentations of the project, of the top 10 achievements that we have in 2025. We will go one by one. Again, I will be very strict with the timer. I will give 5 minutes to each one to present the achievement, and we will start directly with category 1 and the 6G reference project. So today we have with us Hua Wang, who is also a full professor and principal investigator at ETH Zurich. So Hua, please start when you're ready.
Yeah, thank you very much, and good afternoon, everyone. My name is Hua Wang. I'm a full professor at ETH Zurich and Switzerland. It is my pleasure to present the key achievements from our SNS 6G reference project as time-modulated arrays supporting both receive and transmit. Next page, please. It is envisioned that concurrent multi-beam MIMOs will enable numerous new joint communication and sensing applications. And for example, in the 6G distributed MIMO system, and one distributed unit needs to communicate with multiple radio units at the same time with low latency. For situation awareness radars, assuming a drone or a robot is deployed to an unknown environment, the drone will need to quickly understand its nearby environment by probing multiple directions at the same time. Next, it can focus on its intended targets. And further, if we look at the advanced manufacturing, it is critical to link multiple robots and with very low latency at the same time. So, however, a key challenge to achieve the desired multi-beam MIMO functionalities, but ensure and the low and the complexity and the cost is really the problem here. So this is exactly a main topic of our 6G reference project. Next page, please. Although multi-beam MIMO systems can be supported by complex implementations like digital beamforming arrays, and they are not conducive to resource-limited platforms. And to achieve this goal of doing more functionalities but with less complexities, so we explore the time modular array in this project. If we look at the traditional phase array systems, and each element is configured by amplitude of phase shift and on its for its beamforming. However, just within each beam operation, the amplitude and phase settings are essentially fixed values. And this static nature fundamentally limits its multi-beam capabilities. But on the other hand, and besides the amplitude and phase, we can also apply time modulation on each element as a new degree of freedom. And this creates a novel array architecture called the time modulated arrays, which can achieve concurrent multi-beam MIMO operations with one single wire and much simpler hardware. Next page, please. The time modulated array can operate in the receiving mode, so signals from multiple users in different directions can be received concurrently by the same array with only one set of simple analog beamformer. And the independent user information can be streamed in one single wire, and an n element in a time modulated array can achieve and can receive from n+1 directions. Next page, please. Similarly, the time modulated array can operate in the transmitting mode as well. Different signal streams can be combined in the frequency domain and sent to the array, and using one single wire. Next, these signals can be broadcasted and into the multiple directions at the same time. Again, an n-element time modulated array can transmit concurrently to n+1 directions. Next page, please. My team at the ETH is working on the time modulated array and in part sponsored by the 6G reference project. So we have published 2 fabricated chips in 2025 and using GlobalFoundries 22 nanometer FD-SOI technologies in Dresden and Germany. So one chip and is a 140 GHz 4-element time modulated transmitting array, and jointly with a 4-element Butler matrix on the same chip. And this together with antennas, it achieves 20 concurrent beams and support actually 20 concurrent and FMCW radar waveforms, which are shown at the bottom. The signal chip is a 140 GHz 8-element receiver transmitter relay array. It can serve as an active reflective surface to establish non-line of sight channels and with beam steering capabilities. High-speed communications at 1 gigabit per second and 2 gigabit per second are shown on the lower right. So next page, please. This concludes my presentation, and we would like to again thank EU Horizon SNS JU for sponsoring our research and our 6G reference project partners for close collaborations. And thank you very much for your time.
Thank you, Hua, for the excellent presentation. Indeed, an excellent example of how radio and microelectronics can work in synergy to produce excellent results. So many thanks for that. Without further ado, let's move on to the second project in the category 1, significant technology development. So here we have Season and Antonio Napoli, who is project manager at Infinera. Antonio, the floor is yours.
Can you hear me? Yes.
Yes, we can hear you.
Hi, good morning. Good afternoon, everyone, and thanks for inviting me, and for being selected. So I'm going to present this work, which basically could be the foundation for the next generation from front-hauling for beyond 5G, 6G. I would like to highlight that this was a work that we did together with Ericsson as part of the European project Season, and so that's why we are here. So we understood that the next generation mobile transport we need to have a much higher capacity. At the moment, it is still provided thanks to IMDD transceiver. They will need to have very precise timing in the links, and of course the cost must always be reduced. So some of the solution could be provided by, for example, Coherent can provide much larger throughput. The timing error can be solved by using the same fiber, and the cost can be also reduced by using one laser per transceiver. So if we do this and we transmit with a single wavelength, we will end up to have signal that in the spectrum, they full overlap, like in the bottom part of this cartoon. So when the signal full overlap, they excite reflection. Reflection can be caused by the fiber, so this will be the relay back scattering, or by the component. As you can see in this diagram on the right, we are showing here the penalty over the ratio between the signal and the reflection, and what we call full mode, which is a full overlap in the frequency. You can see clearly that the penalty arises quite significant. An alternative to this could be to actually divide our channel already at the transmitter in digital sub-carriers. So this technique is called digital sub-carrier multiplexing. In this case, we use different sub-carrier for the downstream and the upstream, and this has a lot of benefit. In this particular context, it completely cancels the reflection. And of course, there are also other benefits, which could be it enables symmetric and asymmetric traffic and so on. So, but by doing that, we are reducing the capacity significantly. We go from 100% to 50%. So how can we do to do that? So can you go please to the next slide? Then I have only two. Thank you. So we ran an experiment at the Ericsson lab in Genova, in Italy, where we use a point to multipoint transceiver. So this will be another benefit of this technology. And essentially, we actively optimize the power of the individual subcarrier to minimize the impact of the reflection. So in this particular context, if we take one of these contour plot, we are showing the minimum Q. Q is one of the main metrics in optics. The higher, the better, let's say. So we took all the possible paths in that setup. So from and we try to and we are showing the minimum Q. So if we would have done nothing, we would end up in this bottom circle. So with performance that are 1.5 dB or 3 dB lower. By optimizing them, we can actually bring our signal to be transmitted in full mode, and essentially we are enabled almost, or in some cases, 100% full mode transmission. So we have all the benefit, plus we don't lose any capacity. Next slide at the conclusion, and then I finish. Good, yeah. Okay, this was the experiment. So okay, just to show that it was real. And okay, so we show a way to preserve all the benefits that are provided by the transmission over single fiber, single wave, single laser. This is enabled by this technology that we call point to multi-point coherent transceiver, enabled by digital sub-carrier. We achieved 400 gigabit. We did 20 kilometer, but we can do more. And I didn't show here the result, but actually we also save a lot in CapEx, capital expenditure, and in OpEx. Next step will be to have a super accurate model to do this in real time. And actually, we already show a preliminary version at the last conference at ICO. Yeah. Thank you. If you have any question, please contact me.
Thank you, Antonio, for this excellent presentation and the interesting advancements in the mobile transport networks and the interesting numbers that you provided. Many thanks for that. Let's move on to the third project, which is Superiot, and we have with us Bruce Napier, who is Dissemination Manager and EU funding at Vivid Components. So Bruce, please go ahead.
Thank you very much. So yeah, I'm Bruce Napier from Vivid Components, Germany. I'll say a few words about Super IoT's top 10 key achievement, which is related to multi-mode sustainably printed electronics. So if we see, if we could go on to the next slide. There we go, thank you. We could see there our nice logo. We have a lovely green sustainable node emitting in both radio and optical wavelengths. So we have dual mode IoT, and there's a strong emphasis on printed electronics. So we're truly sustainable. So we want IoT everywhere, but we want to do that for as little environmental impact as possible. Next slide, please. So here we have the project in a nutshell. We have dual mode wireless connectivity using either radio and or light. So on the right, you can see at the top, we've got this reconfigurable IoT, this Riot access point, and underneath we have the Riot nodes. So as well as communicating using radio and light, they also harvest energy with radio and light. So these are batteryless nodes. This dual mode aspect improves the positioning, precision, and also gives you a redundant channel, so a more robust performance. And all of these, both the nodes themselves and at system level, is reconfigurable to dynamically select the optimum use of either light or radio. And throughout this, we have sustainable implementation using as much printed electronics as possible. There's a QR code there to a nice overview of our project. Next slide, please. Thank you. So printed electronics, we've done lots of development throughout the project. So you can see here a whole range of things: transistors, sensors, energy storage devices, so micro supercapacitors. We have organic cells, as well as the underlying materials, so the conductive inks, the sustainable substrates that allow these devices. At the end of the presentation, there's a link to our website where there's lots of papers on all of these topics. Next slide, please. So why are we interested in printed electronics? Well, we want IoT everywhere, but we want to have very low cost. So looking at 1 cent nodes, like sticker-like nodes that are everywhere, but to do this with as little environmental impact as possible. In the graphs, you see an example using photovoltaics, either silicon or organic, so printed. And you can see you can have a huge impact in the climate change impact or the resource use from switching from silicon to printed. We could see that we've cherry-picked this example. It's a really extreme one. The situation for the system as a whole and other components is more complex, but the message is clear that the move to printed is a great improvement related to the environmental cost. So there's a nice reference there, and there's another one coming from Super IoT early next year. Next slide, please. Yeah, so how do we get to these printed nodes? We started with a reference node, a reconfigurable IoT node based on silicon technology. Then we replaced as many of the elements as we could with printed electronics, with sustainable substrates and so on. And finally, we hope to demonstrate, so we're in the final month of the project. By Christmas, we think we'll be able to demonstrate the first fully printed node. So this is a major breakthrough for this technology and for this project. It will be energy self-sufficient, completely autonomous, completely printed. Of course, it will be extremely simple. It's the first step, but we hope to have demonstrated this by Christmas. Next slide, please. Yeah, so this is one of our 4 demos. The first was in an industrial environment, so a sticker to track items through a factory. This was a hybrid silicon printed device. You can see there the printed photovoltaic supporting that demo. The second demonstration was a similar application, but in a medical environment. So here we may not be able to use radio in some of the rooms, so the dual modality was very useful. Demo 3, as I mentioned, is this first all printed node. And the fourth one is looking ahead. If we can have large areas of these printed devices, we can have reconfigurable surfaces, these RIS, so-called RIS devices. What could we do with that in the future? So we have videos of all of these. They're in preparation. They'll be online in January. The QR code is there. Join our LinkedIn page, and all the papers are available from the website. Thank you very much.
Thank you, Bruce, and the Super IoT team for these excellent advancements in sustainable IoT, and we're definitely looking forward to your demos that you've just presented. So with this presentation, we just concluded the category 1, significant technology development. Now it's time to move on to the category 2, experimentation. So first project is 6D Sandbox, and we have with us Dimitris Cholkas, the project deputy technical manager and head of research and development at Focus, who will walk us through the achievement of the project. Dimitris, over to you.
Thank you very much for the invitation. Very proud representing here today 6D Sandbox. we have prepared a small video for presenting, let's say, this key achievement. Actually, it is the way that we have followed to realize the experimentation infrastructure as a service model by introducing the trial network concept. And we offer this as an open source software, let's say, under the term 6G Sandbox Toolkit. So we can now start the video.
In the framework of the 6G Sandbox project, SNS JU Stream C, Call 1 project, the 6G Sandbox Toolkit has been developed as a software suite that enables the experimentation infrastructure as a service model. The toolkit creates isolated experimentation-ready networks, or trial networks, on top of network and compute infrastructures. This development has been recently selected as one of the top 10 key achievements of the SNS JU program. The cornerstone of the approach that was followed for the toolkit development was the trial network concept. This concept has emerged as an effort to address major challenges in the current experimentation process over network and compute infrastructures. From the experimenter's perspective, a key barrier is the limited or no access to the underlay network used in the experimentation process. While from the experimentation platform owner's perspective, the key challenge is how to efficiently and automatically share the infrastructure to serve multiple concurrent experimentation demands. To address those challenges, the 6G Sandbox proposed the creation of trial networks, meaning fully configurable and controllable networks, which are defined on shared resources of an experimentation infrastructure, composed of modular blocks based on experimenters' needs, and offered to experimenters as isolated networks, ready for 6G technology validation and KPI measurements. Assuming any experimentation infrastructure with local and cloud-hosted computing resources, as well as with components for data control and experimentation planes, the trial network concept is enabled by expanding the capabilities of the computing infrastructure manager, introducing the so-called trial network plane, which actually refers to the information flows for the trial network's setup and control. This expansion has been realized by the 6G Sandbox Trial Network Lifecycle Manager (TNLCM). The TNLCM also provides the experimenters with an entry point, UI and APIs, towards the underlay network on which the experiments are conducted. Another key innovation in the process of realizing the trial network concept is the hosting of all the network and experimentation-related components to an open repository, called 6G Library, by using a common structure and description model. Given the experimenter's demands, the TNLCM gets component descriptors from the 6G library and automatically deploys and chains the components to create trial networks. As part of the trial network, the TNLCM deploys also the experimenter's favorite experiment lifecycle manager, so the experimenter gets full control of the experimentation process as well. If it sounds very complex, don't worry. The toolkit installer automatically deploys everything to your computing infrastructure. Try it yourself. The code and how-to instructions are available at the 6G Sandbox GitHub. Explanatory videos on how to use a trial network through the TNLCM can be found in the 6G Sandbox YouTube channel as well. Join the 6G Sandbox ecosystem. Already 32 third parties have been engaged through the 6G Sandbox Open Call program, and memorandums of understanding with relevant association and partnerships have been signed. Also, collaborations at company level have been set up, bringing new components to the 6G Sandbox platforms. In addition, the toolkit presentation during EUCNC 2025 has already triggered project external platforms to become trial network ready. Start a collaboration with the project by completing a simple form, available at the project's website, and send it to the experimenter at 6G-Sandbox.eu email. The program for the 6G Sandbox 2026 trials has been launched. 4 main experimentation pillars have been defined: non-terrestrial networks, reconfigurable intelligent surfaces, FR3 focused experiments, and deterministic networking. Thank you.
Thank you, Dimitri. I think this concluded your presentation, right, as well?
Exactly, yes, thank you.
So, many thanks indeed. It is very important to make the life of developers and experimenters easier using the toolkit and the concept of trial network. So this is very, very important achievement also from 6G Sandbox. Thank you very much. Let's move on to the second
In the
project.
framework.
Oops, yeah, in experimentation. Which is Sunrise 6G indeed. So Kostas Ramandas is a senior researcher at iQuadrat, and he will present the achievement of this project. Kostas.
Hi all, thanks a lot for the introduction, Pavlos. So I am Kostas Ramandas, representing iQuadrat, and I am the technical manager of Sunrise 6G. Next slide, please. So Sunrise 6G is a Stream C project like Sandbox. The coordinator is Professor Christos Verikoukis, and I am the technical manager along with Dr. Claudia Carvalho from I2CAT, and project officer is Mr. Pavlos Phenogerakis. Next slide, please. So Sunrise 6G is a federation project. So it federates 14 testbeds, most coming from the Stream C Phase 1 program, some coming from Stream B, and we also have the Slices RI initiative on board. So what is federation? Federation is a lot of things for us. We federate the infrastructures of the testbeds. Next slide, please. You can see the green boxes, meaning that this is how we basically federate the infrastructure of the projects, which allows the vertical applications to deploy at any testbed their applications without caring about the specifics, what kind of platforms. We also federate the experimentation. So you can see the top level red box where the experimenters through the portal can trigger experiments to any of these testbeds through a portal. So we also federate experimentation. Then we also federate some AI processes, so-called the AI Federation, which is out of scope of this key achievement. So I will not present it today. Next slide, please. So let's start with infrastructure federation. This is achieved through our operator platform, where we actually implemented the GSMA standards that are actually used by the operators themselves to federate their networks, to expose their capabilities and edge computing resources, and create multi-MNO federations, which allows them to extend their coverage areas. So then developers can build and deploy their applications to any MNO's infrastructure through Camara APIs. We believe that this is quite impactful because this operator platform will help basically go towards Stream D projects. We believe that it will be adopted by the projects and will help them in trials to deploy their applications and also interface the network, because we also offer some APIs towards the core network. We believe that open source implementation of standards is important because most of the standards do not exist as open source, and this basically impedes research and innovation. Sunrise was accepted as a new SDG by ETSI, and it's now ETSI Open OP, as you can see. Next slide, please. Next slide. Yes, another one. Okay, great, thanks. So another pillar of our federation approach is the federation of the experimentation processes of the testbeds. Here we have the portal, the Sunrise 6G portal, which maybe you have already seen, but there is also the adaptation framework, which is a framework that basically abstracts the details of the experimentation as a service components of testbeds. So we have some common set of APIs to start, stop experiments, and so this allows the testbeds to appear to the testbed through some common interfaces. So this simplifies a lot integrated new testbeds with our solution. Next slide, please. So in each testbed, we assume that there is some type of 6G enabler, and this 6G enabler is available to the community to perform some tests remotely, some remote tests. So this is basically how we create impact. We provide long-term remote access to the 6G library of components, which would not have been available to experimenters otherwise, because they would have to travel, for example. They can trigger their experiments through this unified, simple-to-use interface. It's very easy to onboard some new testbeds. we could do it in one day in our hackathons. And we foster a broader collaboration. Next slide, please. So please let me share. I will just show you the front page of our portal. I don't have time to show you exactly how it works. So hopefully I have the capability to share. Yes, so I will just share my screen. And in order to gain access to the portal, you will just go to our website and you will click Access Portal. And here you can register. We have this link where you can create a new account. This will provide you access. So you can sign into our portal. You can see the test beds, and then you can trigger some tests, but I don't have any time to show you how this works. Actually, you cannot trigger tests because you first have to send us an email to give you right access, but you actually have read access so you can view some experiments. We will be happy to provide you access to also play with this technology yourself. Thanks a lot.
No, thank you, Kostas. Indeed, important innovations in the area of open source and standards compliant federation frameworks for 60 testbeds, but also important the tool for the portal. Important to facilitate the testing and development of 6G applications in the future. So yes, everyone is invited to use this tool and contact Sunrise 6G. So let's move on to the third presentation under experimentation. So it is about 6G XR project. And we have with us Roberto Viola, who is World Package 3 leader and senior researcher at Bicomtech. So Roberto, please go ahead.
Thank you. Thank you, Pavlos, to introduce me. I will say that the CG Sunrise CG was very interesting. I tried it last month at Portal, so it sounds very promising, very useful tool. And so going to my presentation, if you go to the next slide. Okay, we move to the next slide. Okay, CGXR is like the previous two projects, a Stream C project from the first call. And our key achievement is multiple holographic communication integrated in our CGXR testbed. You actually have a demo day, an impact day in few days ago. Well, 1 month ago, it's already, where we show actually this holographic communication. And the video will be also available soon in our YouTube. They are not yet ready, so I cannot show today, but they will be available soon also in our YouTube channel. And if you go to the next slide. Well, first of all, I would say that at the beginning we were proposing two different innovations because we had two different holographic communication coming from two different working packages. And the answers, both of them were about holographic calls, so we decided to present them together. So we have two different scenarios. In the first one, we have holographic communication where we are using the IP multimedia subsystems. So if there is an holographic user sending this information is shared through the IM's data channel, which is interconnected with the 5G core, and this information is then delivered to the holographic user that is here in the image on the right. On the other side, in our working package, we develop another scenario where we don't know about the IP multimedia system, but we are only using the edge computing systems. So in this case, we are supporting the user to interconnect each other directly to the data channel. Basically, the information, the holograms are transferred from the user to the edge. They are processed there through several functions that we can deploy, such as session manager, remote render, reconstructor server, and so on. And all this information, once it is processed, is directly delivered to the user, directly to the user plane. So if you go one by one, these two different communication, for the next slide, I can explain each of them in the next. So the first one, when we are using the IMS, we have the first demonstrator of a network native holographic call. We deploy an augmented reality application in our testbed in 5Tonic in Madrid. Here, the three holograms are generated by a user that is using a smartphone with a frontal camera, where is generated in the point cloud to be delivered to the viewer. This content, this 3D content is processed in the edge in Madrid, where is created the representation, and this is shared thanks to the IM's data channel. you are using the IMS audio for sending the audio, and you are using WebRTC data channel as IMS data channel in order to stream also the holographics. On the consumer, on the viewer part, what we have is the application directly embedded in the smartphone dialer, so you don't need any extra application to be installed in your smartphone, but directly receive it as a normal call. And once you accept this call, you basically start receiving the audio and also directly the holograms in your smartphone screen. If we go to the next one. In the other approach, we are no more using the IMS. We developed several cloud-native network functions that we deploy on top of our infrastructure. In this case, we are not using only the test bed in our laboratory in Phitonic, Madrid, but we're also using the laboratory of I2CAT in Barcelona. So we create an holographic calls between these two different nodes. There is a user in Barcelona generated the point cloud, and this point cloud is received in Madrid. We demonstrated this 1 month ago during our demo day in Madrid. So what we have in Barcelona, if you see on the left in yellow the figure, we have an holographic client which is collecting his 3D representation. This is streamed through the network thanks to the cloud native network functions that are processing this content. We can deploy several functions depending on which the specific requirements of the applications. We have some edge and cloud functions. Some of them are about encoding and decoding the video, rendering, just forwarding like selective forwarding unit, etc. And thanks to these different XR enablers that we develop in infrastructure, we can deliver to the end user, which is on the right of the figure, which can be either a native user, like the one on the left that generated the point cloud, or a simple web page that is receiving a remotely rendered content. So in this scenario, we can enable different users. If you have a laptop with a GPU, you generate the point cloud. They can also view a point cloud from another person. In the case that you don't have any laptop without any GPU, in this case you can rely on the edge and cloud computing in order to perform the processing required and receive in any case the point cloud already processed.
Roberto, please try to conclude because you have used your time.
Okay, yeah. I think I have only the next slide. Only one slide remain. Please, next one. And this is the auto result. On the left you have the AI. On the right you have the VR scenario. And we believe that this innovation opened new opportunities. From the HUMA point of view, we believe that this holographic communication we can facilitate mass market deployment. This thanks to this innovation. Of course, this will create also a new opportunity for new XR application that can penetrate among consumer, professional industries. From the business level, new business model can be developed by telecom operators, AR devices manufacturers, or cloud providers. And from a societal point of view, thanks to edge and cloud, what we developed is several network functions that allow scalability, accessibility, and also inclusion to these XR experiences. Next slide is just some reference, but basically this is the end of my presentation. So if you have any question, we can discuss about this later or write me in the chat.
Thank you, Roberto, very much. I like the potential for mass market deployment of holographic communication. So let's see if this happens when 6G is standardized. So many thanks indeed, and congratulations for your achievement. Let's continue now to category 3, and project, which is about vertical solution and trials. And we have project Imagine Beyond 5G. And Joan Messenger, apologies for the wrong pronunciation if this is the case, who is a researcher IT at Fundación Valencia Port. So, Joan, the floor is yours.
Thank you, Pavlos.
So,
yeah, it's fine. So I'm Joan, and a researcher at Fundación Valencia Port, which is the Research and Innovation Center at the Port of Valencia. And in my talk, I will present the 5G trials that we have performed under the Imagine Beyond 5G project, real trials for real needs in the Port of Valencia, which is the fourth port in Europe in terms of container traffic, and how this has impact in the digital transformation strategy of the port. So the stream, the Imagine Beyond 5G, next please, yes. The Imagine Beyond 5G project is within the Stream D of the SNS program. And the project conducted several experiments across 4 facilities in 4 different countries, Norway, France, Portugal, and Spain. And now we will focus on the experiments that have been conducted in the Spanish facility, more precisely in the Port of Valencia testbed. The Spanish facility is composed of several companies, Telefónica, Nokia, the Polytechnic University of Valencia, Fundación Valencia Port, and Quayside. So the experiments have been run in a testbed, in a 5G standalone node that is located in the Port of Valencia as a single node in a testbed as part of this Spanish facility. So next, please. Next, yeah, thank you. So in Imagine Beyond 5G project, we have run 5 open call trials, pilots in the Port of Valencia. In ADAPT-G, we have developed an advanced surveillance system capable with a drone remotely controlled with 5G to perform unattended monitoring patrolling as to detect open gates or intrusions in restricted areas. All these video feeds going in real time to the digital twin of advanced control emergency center. And we have also, following with the PPDR, we have also implemented the Rescue 5G trial where we have remotely controlled through 5G USB, which was to perform first aid rescue operation, also capable to collecting objects on the surface. Then in 5G Build-to-Fix, we evaluated how 5G can be used for remote maintenance, more precisely to guide the field maintenance operators remotely from experts that are located in other places, so that they can, through augmented reality, follow the steps that were marked by the experts in remote. Next slide, please. In PortSafe Beyond 5G, we have tested network slicing to put the network to the limits, so that we can combine several network throughputs from different devices, so drones, UGVs, and robots. And in 5G Abyss, we remotely control a motorboat to make a coverage test offshore, as well as combine commercial and private networks to extend the coverage in the port area. Next, please. So, well, as you know, in the current geopolitical situation in the world, ports are critical infrastructures. They need to be resilient, and having private 5G private networks, it's a must to build a connectivity bubble independent from commercial networks and city networks, so that they can ensure the transport of goods which is extremely important. For that reason, the Port of Valencia, in its own strategy, they wanted to deploy a 5G full private network, and they are in process, because actually beyond this project, Imagine Beyond 5G, and these trials have helped the Port Authority to understand and to test the 5G technology, so that the RFQ, the tender, was very precisely defined with all the connectivity requirements, so that to deploy a network that is composed of around 17 base stations and 39 antennas, covering the 98% of the surface of the whole port. This is performed under the Connected Europe Facility project called 5G Valencia Port, with a budget of 6 million euros. So these experiments I was explaining to you were very important for the definition of the RFQ. In fact, in this project, in the deployment of the 5G private network, we will deploy in production 2 of the 5 pilots that we have and that I have explained, AdaptG and Virtufix, as production services. So this is really important to see how these SNS projects help industries to understand and to make the pilots real as a production services. We are looking forward to experiment with 6G already, because you need to take into consideration that these infrastructure are very complex, so they require very advanced wireless technologies.
You
so
try to conclude, because you have consumed all your time. Yeah.
Yes, I am done actually. So thanks a lot for the SNS program to give us this opportunity. Thank you.
Thank you, Jon. Indeed, impressive real-world demonstrations of Beyond 5G capabilities in real operational port environment, and of course integrating different technologies, AI, AR, drones, remote vehicles, many things. So indeed, very impressive.
Thank you.
Let's move on to the second project and key achievement in the vertical solution and trials. We have a TrialsNet project, and Silvia Provedi with us. Silvia is a project coordinator and senior project manager at Ericsson. So Silvia, please go ahead.
Thank you, Pavlos, and I'm very pleased to be here. Please go on with the next slide. I will speak about what happened in the Movistar Arena in Madrid on the 16th of March this year, where many innovations were deployed during 2 basketball matches. The day started very early for TrialsNet partners that arrive at 7 o'clock in the arena and started the deployment of the network infrastructure. That is a state-of-the-art 5G Release 17 standalone private network running on millimeter wave with local UPF. And this is the first deployment of this kind in Europe. 3 antennas and 4 CPEs were installed to cover the court and the places around, and other video cameras and production equipment were installed. At 12:30, when the first basketball match started, everything was ready and working for running 2 use cases. This portable 5G standalone solution has demonstrated to support large-scale events and provide high throughputs and low latency, which enable new services that were previously limited by wireless and the local setup. Please go on with the slide. The 2 use cases that were demonstrated belong to different domains One is on media XR, the other on safety. The first is the immersive fan engagement, that has the objective to broadcast the basketball match through mobile and VR streaming. The cameras that were around the court sent the feed to a remote video production that redistributed the images to the smartphone and the VR set. In this way, the fans using the smartphones were able to see the match from a different angle to personalize their experience. And this additional service can be included in the event ticket. At the same time, people that were on the hallway dressing a VR headset could live the VR experience of the match. The second use case is the smart crowd monitoring that has the objective to validate a wireless safety framework in such a demanding environment like this stadium. This use case was validated in the entrance part of the arena. There were sensors, ground robots, leaders, and through AI algorithms working locally and on the cloud, any anomalous situation, any object left was identified, and this information were handled remotely by safety personnel in the ISOC control room. Please go on. This key achievement has proven that 5G revolutionized fun experience and safety in real events, and even more that 5G unlock next generation experience services and gives new opportunity of business. We believe that this key achievement marks a breaking point in live events. Thank you for your listening.
Thank you, Sylvia. Again, very impressive real-world trial. As myself, a big basketball fan, I would really be eager to test all this experience for the remote experience for fans, but also important aspect, the public safety and the operational efficiency in stadiums. So many thanks once again for your important achievement. So now we move on to category 4, which is about impactful standards contribution. And here we have an achievement of Project 6 Design, and Zilberto Berardinelli is with us today. Zilberto is a project coordinator and associate professor at Aalborg University. So, Zilberto, the floor is yours.
Thank you, Pavlos, for the introduction. So good afternoon, everyone. It is my pleasure to present here our achievement related to INEX architecture and integration into the CG network of networks. Next slide, please. Yes, just to spend a few words on the project to give a bit of context. 6G Shine is about pioneering the main technology components for INEX subnetworks that are short-range, low-power radio cells that can be installed in entities like robots, vehicles, production modules, classrooms, to deliver highly localized and high-performance connectivity. Use cases and applications of some networks can be very diverse, but a common characteristic, said in a nutshell, is that some networks should be able to operate autonomously to a certain extent, similarly to ad hoc network, while at the same time they can benefit of being a part of a larger CG network, of a larger CG ecosystem. So in 6G Shine, among other things, we have developed the architectural foundation for those INEX subnetworks. And in particular, this achievement defined the key building blocks that can enable those subnetworks to operate to a certain degree autonomously, while remaining seamlessly integrated into a broader 6G network. Next slide, please. Just to give a few more details, what we have defined in this project is the key elements for the INEX subnetwork architecture, the key components. For example, as we can see on the right side of the slides, components such as the subnetwork element that can be a low-cost sensors and device, the low capability device, which may have a low networking capability, and the high capability device that can be equipped with higher networking capabilities. So, for example, some network elements and low capability device can form a subnetwork and be connected to a management node, which can be the node that is able somehow to connect with the 6G parent network. So within the project, we have defined those key elements, roles, communication modes, and what we call intra-subnetwork enablers. So all those enablers that allow a local subnetwork to be able to operate efficiently. So defining a subnetwork routing mechanism, device group function, but also authentication and node management. And also, let's say, those mechanisms that ensure survivability and performance continuity in the absence of apparent network connectivity. Also, since the subnetworks can be located close to each other, we defined the enablers for inter-subnetwork communication, so enabling collaboration, task offloading, and functional extension across multiple subnetworks. And last but not least, the mechanism for integrating with the parent 6G network, so orchestrating functions across the RAN and the core network, but also support for non-3GPP technologies and offloading to the core network. Next slide, please. Yes, we are particularly proud that a use case defined by some of the project partner on in-vehicle subnetworks, in-vehicle local communications, and build upon the architectural approach of the project has been already captured in the 3GPP in the TR 22.870 study on 6G use case and service requirements. So for this use case, actually relates for local communication inside the car, for example, for certain control functionalities in the car, but also for infotainment. So this in-vehicle communication will be using configuration and radio resources received from the mobile network. So coherently with our architecture vision, this in-vehicle network should be able to a certain extent to operate with partial autonomy when out of coverage, for example, of a parent network, like a car driving in a tunnel or where there is no coverage from the parent network, following predefined network policies. And this local control in the car can handle also authorization, resource allocation, and device configuration for in-vehicle communications. So we believe this is some of the first step to bring our ideas, our concept further, and hopefully become a 6G reality. So this key achievement, we believe, somehow provides the groundwork for future short-range wireless networks that can that are capable of meeting very demanding requirements of several use cases. Now we talked about in-vehicle, but they can be industrial and also consumer applications. So if you are interested, we recommend you to have a look at our website, and in particular to our deliverables. They are public in the website, in particular deliverable D2.2 and deliverable D2.4, because they deal with the use cases and the architectures. Yes, this is all from my side. Thank you.
Thank you, Gilberto. No, indeed, important technology and a lot of applications for the subnetworks, and most importantly, important input in the discussions at 3GPP level. So this is very, very important for European influence on global 6G development. So many thanks for that. Then we, last but not least, of course, we go to category 5 and the sustainability solution. We have our flagship project, Hexa X2, and Miko Usitalo with us. Miko is a project coordinator and head of radio systems research department at Nokia Bell Labs. So Miko, the floor is yours.
Yeah, thank you, Pavlos. Thanks for the invitation. And yes, let's move forward with the presentation. So yes, I'm coming from Nokia Benelux Finland, being also the site lead here, and had the pleasure to lead this and have Nokia as overall leader for the HexaX2 European Level 6C flagship, where Ericsson was in technical manager role, and we had, as you can see here, really good consortium covering the entire value stack, operators, technology providers, SMEs, high quality academia. And as you can see from the next slide, showing the overall things we were active with. So in the next slide, in this slide, so we're working on the use cases, technologies to realize those use cases, also combining 100+ technical enablers of ours and from other projects into end-to-end system blueprint, so interactive with other projects. But then going to actual technical topics in the next slide of this presentation. So about the use cases that we were working on, that were the basis. Could I get the next slide? The basis for the European level input also to the 3GPP process that started on use cases for 6G 1.5 years ago. This process at European level was coordinated by SNS JU, but this was the main input. In the center, you see the sustainability dimensions, be it environmental, be it social, and be it economic sustainability, driving the analysis of the use cases. In the circles, you see the use case families, and in the boxes next to those, also individual use cases under each use case family with the so-called representative use case topmost. So we had these immersive experiences that was, for example, here shown in the context of the basketball match, collaborative robots, having a set of robots, understanding our needs, serving us based on our needs, even though not explicitly expressed. Physical awareness, building on top of this, understanding the environment and sensing by 6G. Digital twins, already saw some examples of that creating the kind of management of the physical environment more efficient, and also planning and designing. And fully connected world, remote locations, also bringing the kind of connectivity at lower price points, as well as trusted environments. Then in the next slide, you can see an example of the analysis we did with respect to sustainability for all these use cases. Here is just an example of one use case where we delivered like analysis of the handprints or the benefits and the footprints, the cost of each of the use case from all of these dimensions, be it environmental, social, or economic. And then in the next slide, you see further work that we did based on the use case analysis. So we were looking at what kind of devices are needed for 6G that come from these use cases. And for example, recognize the need for energy neutral devices used for sensor tags or stickers that are then analyzed further in the next slide, showing that these energy neutral devices can be used for all of our use cases. I guess the next slide is about to come. For example, for tiny Internet of Things devices, harvesting energy from the environment, enabling perpetual maintenance-free and environmentally friendly IoT applications, and passive zero-energy devices making use of backscatter communication. So you don't have any energy source in the device, you get some communication exposed to that device, and then with the energy of this communication, the device is able then to communicate back or even do some sensor readings based on that energy. Our main contributions in this zero-energy device connectivity area were methods to create more sustainable zero-energy device hardware, optimizations to reduce overhead in the radio access network, reducing energy and resource usage. And we also made a proof of concept in this domain, showing backscatter ambient cellular signals, reducing operational cost for passive zero-energy devices by up to 90%, and so to use it as a tag for indoor localization, showing room-level accuracy. And that covers my presentation, but in the next slide, there is also, as a reminder, like main deliverables from the project that bring much more details on the results that I mentioned, available from our website. So thank you.
Thank you, Mikko. Excellent and impactful results from HexaX2, and especially the ones that you mentioned on the definition and adoption by 3GPP on the 6G use case families, with sustainability in the heart of these use cases, but also on the introduction and proof of concept on the zero energy devices. So important results. Many thanks for that and the presentation. So now I think we reached the end of this session about the project presentation. I know we're running late, so I would like to ask you for a few more minutes, 5 more minutes, if you can stay with us. We have a question in the chat that we would like to address to category 1 project presenters. The question is about what the next step needed to bring the presented innovations closer to market readiness or standardization. So please, who would like to take this from a 6G reference, Season and Superior?
Go ahead.
Go ahead.
Okay, maybe I can. I'm happy to take a first step at this question, and thank you very much. And this is a very important question, and this is Hua Wang from ETH Zurich and from the 6G reference project. So I think, if I may speak on behalf of our time modulated array technology, and in our 6G reference and the project, we have made the kind of experimental demo and using more like a customized chip. So I think that the next step if we want to bring this innovation closer to the market readiness, I think it's we should move forward with the demonstration, particularly with an existing and kind of mass producible and the chips, and to show that the functionality as well as the cost benefit are still being achieved using these and often on the market chips. I think that will bring the technology really closer to the market readiness. Yeah, rather than using only the lab-based and kind of customized chips. Yeah.
Thank you, Hua. Thank you very much. I can go to Bruce. Bruce, from Super IoT perspective.
Yes, thank you. Yeah, from Super IoT, it's very similar to Hua's answer, that it's all about upscaling. So we focused on the printed electronics and the LCAs to show the advantages environmentally and cost advantages compared with silicon technology. But you're comparing lab processes with the huge volume production of silicon electronics. It's very hard to do an accurate, a realistic comparison of the two. And you really need to upscale the production of the printed components and systems before you can get the real benefits.
Thank you, Bruce.
So a similar answer, I guess.
Yes, but indeed it applies also to you, but many thanks for the valid answer. So I don't see any other question, and we don't have any available time anyway. So I think it's time. Yes?
Yeah, yes. I couldn't unmute myself, so that's I mean, I was listening to you.
We couldn't listen. So, Antonio, yes, if you would like also to add, you have a few seconds, let's say.
Yes, concerning our work, we are actually extending with our partner in Ericsson in different way. There is the physical layer. I'm a more physical layer guy, but also the guys who were involved, but their colleagues are also asking more things that could be more at the management level. So actually, how to do from a real operational point of view what we did show in the lab. So yes, the answer is we are continuing this. Yeah, we are continuing to collaborate.
Thank you, Antonio. Thank you as well. So now, as said before, it's time. I think it's time to wrap up. Today's webinar showcased the top 10 key achievements, and what we have seen was really groundbreaking advancements in different technology areas, but also in experimentation, in real-world trials, sustainable use cases, and many more. So indeed, I would like to once again encourage all of you to explore the Key Achievements Repository on our website, the SNS JU website, with a full set of 188 achievements. And I would really invite the stakeholders also to engage with the project work, to understand the impact, identify opportunities for collaboration, or for further development of R&I towards standardization, as mentioned also in the introduction of this webinar. And you have to stay. You have to rest assured that this is not the end of the road. As also Costas mentioned in his presentation, within 2026 we will have the second iteration of the key achievement selection process, trying to give the opportunity also to all our ongoing projects, including the 16 projects in Call 3, to present their significant up-to-date results of European connectivity research. So I would like to warmly thank all the presenters and the participants, and in particular the researchers and the project teams behind these remarkable results that we have all seen today. And of course, I would like to thank the entire SNS community for their continuous commitment in connectivity research in Europe, the SNS Co-op team, and of course our SNS JU communications team for the impressive work in the collection, the evaluation process, in setting up the repository tool, and of course for the excellent preparation of this webinar. Please be reminded that the recording will be available soon on our website and on YouTube, if I'm not mistaken, yes. And we look forward to seeing you at our upcoming SNS events and to continue this 6G journey from research to real-world impact. So have a great day and bye for now. Thank you.